Now we have a number of parameters that we use. We use a number of parameters to measure the strength and direction of the association between the two ranked variables. And one of them is called Spearman's rank correlation coefficient. It is used to determine the level of correlation or how two variables are associated with each other. Are they having a linear relationship? Are they having a strong association? Of course, if they have a linear relationship, but do they have a strong association? Are they highly related with each other? So we use Spearman's rank correlation coefficient, whereby we arrange our data in ascending or descending order. Then we give ranks, starting with the smallest. So we give the smallest, we give it rank 1, the next we give it rank 2, the next we give it rank 3, and so on and so forth. So now, this is Spearman's rank correlation coefficient. And we are saying it measures the strength and direction of the association between ranked variables. Data can be ordinal or ranked or continuous. Then it does not assume a linear relationship, but a monotonic relationship. A monotonic relationship is where data continuously increases or decreases. So if you have, for example, a distribution of this nature, this is showing a monotonic relationship. It has when it is increasing consistently and then when it is reducing consistently. So the formula is represented by this symbol. We have symbol rho, and that rho is equal to 1 minus 6 sum of di squared divided by n into n squared minus 1. And this is what we call the Spearman's rank correlation coefficient. D is the difference in the ranks of the what? Of the when it is negative, there is a perfect negative rank correlation. When it is equal to 0, then there is no correlation. Then we have what we call the Pearson correlation coefficient, and we shall see that this is the same as the product moment is called the Pearson product moment coefficient. So wherever you are going to be checking in, maybe in the past paper questions, and you find they are talking about the product moment coefficient, then just know they are talking about Pearson correlation coefficient. So it also measures a linear relationship between the two continuous variables. Both variables should be continuous and normally distributed. So where you have a normal distribution, then you can use a Pearson correlation coefficient. Then what about the relationship between variables should also be linear, okay? So there you use the Pearson correlation coefficient. Now this is the formula, and this is you will have data arranged in the form of x and y. You could have the performance of physics and chemistry. So you get the data. So physics can be represented by maybe x, chemistry can be represented by y, and then they are asking you to determine whether there is a relationship within the performance, between the performance of physics and chemistry. And then you will need to use that formula. Then the bar means, of course, the average. So you total and you get the average, that is the mean. Then y bar is also the mean of the data, divided by the square root of sum of x minus a mean, then squared, y minus y bar squared, you sum. So that r, once it is also equal to 1, then there is a perfect positive linear correlation. If it is negative, then there is perfect negative linear correlation. When it is equal to 0, then there is no linear correlation. We have said this is the same as Pearson product moment correlation coefficient. It measures the strength and direction of the linear relationship between two continuous variables. Involves summing the products of the paired deviations of the variables from their means and then normalizing this sum by the product of their standard deviations, which is shown here. R is the Pearson correlation coefficient, I and yi are the individual data points. Then x bar, y bar, as we said, they are the means.